in this section we're going to do U substitution. Now U substitution is just a fancy backwards chain rule. So if you remember the chain rule from your derivatives, the U substitution is just the chain rule done backwards, and we just call it U substitution. So the idea of U substitution is that if your integral is a function multiplied by its own derivative or multiplied by something that's close to its own derivative, then we can substitute, you can make a substitution that would make the integration process a lot easier. Let's take this first question as an example. This is question 1 from section 4.5 of Stewart Calculus, the 8th edition. So any question that I'm doing, if you look up here, you will find the source. It's from the 8th edition of Stewart Calculus. Okay, so let's take this question 1 as an example. So we've got integral of cos or cosine of 2 of x dx. Now I can rewrite this as the integral of 1 times cosine 2x dx. Now I notice that the integral of this, or the derivative of this 2x, is 2, which is just 1 multiplied by 2. So this function is in fact multiplied, or this 2x here is multiplied by its own derivative, but that derivative is just divided by 2. So we could have our u equal to 2x, and let's put it du. Well, du will be the derivative of u, which would be 2 dx, but we don't want a 2, we want a 1, so we'll divide both sides by 2. So a half du would be dx. And now if I make this substitution into my original integral, I will get the integral of cosine of, now instead of 2x, I'm going to substitute my u du, but I have to multiply the whole thing by a half because du is actually 2x. And to see this, if you substitute back in u, so let's put our 2x back instead of u, we'll get cosine, and u is 2x, and du, according to our formula here, du is 2 dx. And I've got this half out here, and I can cancel this 2 with this half, and I'm back to the original integral. Alright, perfect. So now you see that how we do the substitution, it doesn't actually change the value of the integral, but it can make integration much easier. So let's integrate this. Let's use the substitution to integrate. So we've substituted here u for 2x. And now I'll integrate this. Notice this is much easier to integrate, cos of u or cosine of u, than cosine of 2x. So this is why we do the substitution. And the integral of this would be a half into, now the integral of cosine is just sine of u. And we'll add a constant as always when we're integrating. And now if I substitute my u's back for x's, because I want my answer in x, not in u. Well, u is 2x. I've got a sine of u here, so it turns into sine of 2x plus c. And I can simplify that further. It will be sine of 2x over 2 plus c over 2. But c over 2, c is a constant over 2 remains a constant, so I can just leave it as c. So that would be my final answer. Okay, let's do another question. These questions start off easy, but they get progressively harder and harder. So this is question 2. We have this integral x into 2x squared plus 3 all squared. I noticed that this here, 2x squared plus 3, if we derive it, we will get 4x. And that's pretty close to this other function here. So I've got a function multiplied by its derivative multiplied by some constant. So if I take my u as 2x squared plus 3, and my du would be the integral or the derivative of u, which would be 4x dx. Now that's good. I want an x dx. See, I can substitute u for this, and now I need x dx. I've got a 4x dx here, so I will divide by 4, both sides by 4. So a quarter du would be x dx. And now I can go ahead and make my substitution. I'll leave the quarter outside. And this turns 2x squared plus 3 turns into u. And that's all raised to the 2. It's u squared. And my x dx is just a quarter du. And as you can see, this is a much simpler integral to evaluate than our original integral. So we've got here 1 over 4. And to integrate, I just add 1 to the power. U, 2 plus 1 is 3. And I'll divide by that power, 3. And I'll put my c. Okay. Now I'll substitute my x's back in. My u is equal to 2x squared plus 3. So I've got 2x squared plus 3 all cubed over 3 plus c. Alright, and I put the quarter inside. I'll get 2x squared plus 3 cubed all over 4 times 3 would be 12 plus c over 4, which can just remain as c. So that's my answer. Next question. Okay, again here I see that this x cubed plus 1, if I take the derivative, I'll get something close to x squared. The way you spot these is if you have, say you have two x's and one is raised to a power and the other one is raised to a power just below it. Or so here you've got an x squared and then here you've got an x cubed. That's a clue that you should use the u substitution. Okay, so for this one here, I'll let my u equal to x cubed plus 1. So the whole thing inside. And my du would just be the derivative of that, which would be 3x squared dx. Okay, I need an x squared dx, not a 3x squared dx. So I'll divide both sides by 3. That would give me a third du is equal to x squared dx. And now I can go ahead and make my substitution. I'll keep the 1/3 outside. And I'll get square root of u du. Okay? Before I integrate, I'm going to rewrite this integral as u to the power of a half du. Okay, so raising something to the power of a half is the same thing as square rooting it. Alright, so we can go ahead and integrate this now. So I'll keep the third outside. Well, a half plus 1 would be 3 over 2. So u to the power of 3 over 2 divided by 3 over 2. And I'm going to add my constant. So that would be a third. I'll place my x's instead of the u's, which will be x cubed plus 1. X cubed plus 1 all to the power of 3 over 2. And I'm going to take this denominator and flip it over and multiply. I'll get times 2 over 3 plus c. Okay, simplify that further. I'll get 2x cubed plus 1 to the power of 3 over 2, all divided by 9, because you've got this 3 and this 3, plus c. Well, it's c over 3, but a constant over 3 will just remain constant. And that would be my final answer. Okay, next question. Okay, so I hope you're seeing the method we're using here. The questions will get harder, but the idea remains the same. So here, I know that the derivative of sine is cosine, and so I can make a simple u substitution here. So I'll let u be sine of theta, and du would be cosine of theta d theta. And this is perfect. I don't need to do anything. This is exactly what I want, which is cosine of theta d theta right here. So I'll substitute in my u. So my u is sine, so this will be u squared. And cosine theta d theta is just du. Alright, and if I integrate this, I'll get u cubed over 3 plus c. Okay. Now I'll substitute back because I want it in thetas, not in u's. And so u is sine theta, so I'll get sine cubed of theta over 3 plus c. And that would be my final answer. Next question. Here I've got x to the power of 4, and up here I've got x to the power of 3. So x to the power of 3 is just a quarter of x to the power of 4, or it's the derivative of x to the power of 4 divided by 4. So if I make my u as x to the power of 4 minus 5, and my du would be 4x cubed dx. Okay, but I just want an x cubed dx, so I'll divide both sides by 4. I'll get x cubed dx. And now I can make my substitution. Again, I'll leave the 1 over 4 outside, and I'll get 1 over u squared du. Okay, so this x to the power of 4 minus 5 has turned into u, and I square it. And the rest, x cubed dx, is just a quarter du, this here. Okay, so before I integrate this, I'm going to rewrite it as 1 over 4 to the integral of u to the power of minus 2 du. And now the integration has become simple. It's just we add 1 to the power and divide by the power. U to the power of minus 1 over minus 1 plus the constant c. Now if I distribute in, or first let me put in my u, I'll get 1 over 4 x to the power of 4 minus 5 all raised to negative 1 divided by negative 1 plus c. Okay. Now I'll get 1 over 4 multiplied by, well, this negative 1 can just go outside as a negative, and this here would be 1 over x to the power of 4 minus 5, because it's to the power of negative 1, so it just drops down to the denominator, and got plus c here. Now I could distribute this quarter inside, but I'm just going to leave it like this. I think it looks cleaner this way. Okay, so next question. For this question, square root of 2t plus 1 dx, or sorry, there should be a t here. So square root of 2t plus 1 dt. I'm going to let my u be 2t plus 1. du would be 2 dt. And I don't need a 2 dt, I only want a 1 dt. So there's a 1 dt here. So I'll divide both sides by half. So a half du would be dt. And now I can substitute in my u's. It'll be square root of u du. Alright, so I'm going to rewrite this integral as u to the power of a half du. Okay, so here there's a half out here and a half out here because of our du. And now I can integrate this as a half into u to the power of 3 over 2. I'm just adding 1 to the power and dividing by that power plus c, and that would equal to a half. Well, my u is 2t plus 1, so I'll write 2t plus 1 to the power of 3 over 2, and I'm going to multiply by the reciprocal of the denominator, which is 2 over 3 plus c. I can simplify that further, put this half back in. I'll get 1 over or 2 over 6, or that would simplify to 1 over 3 into 2t plus 1 power of 3 over 2 plus c. Okay, so this 1/3 comes by multiplying this half by this 2 over 3. You'll get 2 over 6, which is 1 over 3. And that would be our final answer. Next question. Okay, I know that 1 plus cosine of t, if I take the derivative of that, I'll get negative sign. So I'm going to make my u 1 plus cosine of t, and my du, there should be a t here again, and my du would be negative sine of t dt. Okay, but I don't want this negative sine t dt, I want just sine dt, so I'm gonna multiply by negative 1 both sides. I'll get a negative du equals sine t dt. Alright, and now I can make my substitution. I'll leave the negative outside. I'll get square root of u du. Okay, and this is simple to integrate. I'll rewrite it again. I'll rewrite it as the integral of u to the power of a half. And that integrates to negative u to the power of 3 over 2 divided by 3 over 2 plus c. I can clean this up by saying negative 2 over 3 u to the power of 3 over 2 plus c. Okay, so I just rearranged everything. I took the denominator and flipped it over and multiplied by the numerator and took this negative inside. And now all I've got left is to substitute for my u's. And this, you've got a u here, and u is 1 plus cosine of t. So it will be 1 plus cosine of t all to the power of 3 over 2 plus c. And that would be our final answer. Next question. It's the integral of sine of 2 theta over 3 d theta. Now this 2 theta over 3 d theta is what's causing the problem. I mean, if you had sine x, the integral of that is simple. It's just negative cosine of x. It's really this 2 theta over 3 that's causing a problem. So I'm going to let my u equal to 2 theta over 3. My du would be 2 over 3 d theta. Okay, but I don't want 2 over 3 d theta, I just want d theta. So I will move this 2 over 3 to the other side and it'll become 3 over 2. Du would be d theta. And now I can set up my integral. I'll leave the 3 over 2 outside, substitute my 2 theta over 3 for u, du, and that has become a simple integral. So I'll leave the 3 over 2 outside. The integral of sine is negative cosine. So negative cosine u, and I'll add in my constant term. And I simplify further, it'll be 3 over 2 or negative 3 over 2 cosine of u plus c. So I just distributed this 3 over 2 inside. C times 3 over 2 is just c. It's just another constant. So we don't bother writing the 3 over 2 for that one. And now I'll put back my u as 2 theta over 3. So I'll get negative 3 over 2. And I'll have cosine of 2 theta over 3. Okay, next question. The question says find the integral of secant 3t times tangent 3t dt. Okay, for this this question is easy if you remember that the derivative d over dx, or the derivative of secant of x, is just equal to secant of x tangent of x. Okay, and that means the integral of secant of x tan of x is secant x. So I'll let my u be 3t, du would be 3 dt, and therefore I'll get a third du equals to dt, because I only want dt, I don't want a 3 dt, this is not multiplied by 3. And now I can set up an integral. I'll leave the third outside, and I'll get secant of u tan of u du. And now I've got this standard integral, secant x times tan x. Here I've got secant u times tan of u du, and that integrates simply to 1 over 3 into secant of u plus c. Okay, and all we have to do now is insert our u, which is 3t, plus c, and that would be our answer. Next question. Okay, so we've got sine, or the integral of sine of the square root of x, all divided by the square root of x. So I'll let u here, I think it's obvious, it'll just be square root of x. Okay, because I know how to integrate sine. Our problem is the square root of x and this square root of x down here. And du would just be 1 over 2 square root of x dx. So if you take the derivative of square root of x, this is what you would get. Now, we don't want a half times 1 over square root of x, we just want 1 over the square root of x dx. So we'll multiply both sides by 2. We'll get 2 du would equal to 1 over the square root of x dx. Alright, and now I can put my substitution. I'll leave the 2 outside. I'll have sine of u du. Okay, so if I put back u as square root of x and du as 1 over 2 square root of x, I'll get back to my original function. Okay, so now I can integrate this easily. I know it will be 2 into Integral of sine is negative cosine plus c. And that simplifies to negative 2 cosine, and the u is square root of x plus c. Okay, next question. So the question says take the integral of secant squared theta tan cubed theta d theta. Now we have to remember, for this question, we have to remember that the derivative d over dx of tan of x is secant squared of x. Okay, so we can use this to our advantage and make a substitution, because now we know the derivative of this function here is secant squared x theta. So I'll let my u equal tan of theta. The du would be secant squared theta d theta, which is exactly what I want, secant squared theta d theta. And I can make my substitution now. I'll get u cubed du. Okay, now this is a simple integral, u to the power of 4 over 4 plus c, and I'll substitute in tan theta for u. I'll get 1 over 4 tan theta to the power of 4 plus c, and that would be the final answer. So as you can see, for u substitution, if you know your identities, if you know these standard derivatives and standard integrals, it becomes very easy. Next question. It says take the integral of sine x multiplied by sine of cosine x dx. This is not a simple question. It might not be obvious at first what we have to do, but it is a u substitution. So I'll let my u equal to cosine of x. Du would just be negative sine of x dx. That's the derivative of cosine of x. And now I just want a dx. I don't want a negative sine x dx. So I'll let my du be negative du equals sine of x dx. Alright, so I'll substitute now. I'll get the negative, I'll leave the negative outside, integral of sine of u du. Okay, so if we substitute back u in, I'll get sine of cosine of x, and then du is negative sine x dx, which gives us this sine of x and this dx, and we've got a negative out here which cancels out with this negative. So our substitution is good, it's okay. And now this changes to, well, the integral of sine of u would be negative cosine of u plus c. Okay, and if I distribute this negative inside, I'll get cosine of u plus c. Now this cosine of u can be written or rewritten as cosine of x plus c. Alright. Great. Next question. Okay, for this one, I see this is an x cubed and this is an x squared. So if I take the derivative of this in here, I'll get this x squared, and this x will disappear, and I can divide everything by 3, and I'll get x squared plus 1. So I'll take u as x squared plus, or sorry, u would be x cubed plus 3x, x cubed plus 3x, and du would just be 3x squared plus 3 dx. I'll divide both sides by 3. So 1 over 3 du would be x squared plus 1 dx, which is exactly what I want, this x squared plus 1 dx. Okay, so I'll substitute that in. I'll leave the 1 over 3 outside. I'll get u to the power of 4 dx, right? Because this u is just this x cubed plus 3x to the power of 4, and the du should be a du here. This du takes care of the, or this 1/3 du takes care of the x squared plus 1 dx. Alright, so now I can integrate this 1 over 3 into u to the power of 5 over 5. I add 1 to the denominator and then divide by that new denominator plus c, and that would be u to the power of 5 over 3 times 5, which is 15, plus c. Now my u is x cubed plus 3x. I'll substitute that in. X cubed plus 3x all to the power of 5 all divided by 15 plus c. Okay, next question. Okay, I've got a cosine of pi divided by x all divided by x squared dx. So for that I'm going to take my u as pi over x, and my du would just be minus pi over x squared. So if you take the derivative of this, you'll just get minus pi over x squared. Okay, so I want this 1 over x squared dx. So I have to get rid of this negative in this pi. So I'll divide by negative pi. This negative 1 over pi du would equal to 1 over x squared dx, which is what I want, 1 over x squared dx. And now I'll just leave this 1 over pi outside and integrate cosine of u du. And the integral of cosine is just sine of u. Sorry, it's negative 1 over pi sine of u plus c. Okay, and if I distribute this, I'll get negative 1 over pi sine, and u is pi over x plus c, and that would be my final answer. Right, next question. The question says take the integral of 1 over cosine squared of t all into the root of 1 plus tan of t dt. Okay, for this one we have to remember again that the derivative of tan of t is secant squared of t. Okay, so that's a standard derivative. And then we need the identity that secant of t is just 1 over cosine of t. That's what secant means. Secant means 1 over cosine. So secant squared of t would be 1 over cosine squared of t. So once we know that, we can go ahead and let our u be 1 plus tan of t. Okay, and du would be the derivative of this, which would just be secant squared of t dt, and I can rewrite this du as 1 over cosine squared of t dt using our identity. Okay, so this 1 over cosine squared t of times dt is exactly what I want, which is 1 over cosine squared t dt here. And so I can make my substitution. I'll get the integral of 1 over the root of u is 1 plus tan of t, and this du takes care of the rest, 1 over cosine squared t dt. Okay, so this, we can integrate this, but I'm going to rewrite it first as u to the power of negative a half du, and that would just be u to the power of a half all divided by a half plus c. I'll rearrange this. I'll get square root of u multiplied by 2. Just took this denominator, flipped it over, plus c, and our u is 1 plus tan of t. So 2 root of 1 plus tan of t plus c. Alright, next question. It says take the integral of the square root of cotangent of x all multiplied by cosecant squared of x. For this we have to remember that the derivative d over dt of, or dx, sorry, of cotangent of x would be negative cosecant squared of x. So you have to remember this standard derivative. Okay, so once we know that, well, we have cosecant squared of x here, and we have cotangent of x. So we'll let our u equal to cotangent of x. Du would be negative cosecant squared of x dx. But I don't need this negative, so I'm going to multiply both sides by negative 1. So I'll get negative du would equal to cosecant squared of x dx. And I'll make my substitution now. I'll leave the negative outside. I'll have the square root of u, and this negative du takes care of the cosecant squared x dx. Alright, and before I integrate, I'm going to rewrite this as u to the power of a half du, and that would equal to negative into u to the power of 3 over 2 divided by 3 over 2 plus c. And if I just distribute this negative in and pull out this denominator, multiplied by the, flip it over and multiply by the numerator, I'll get negative 2 over 3 u to the power of 3 over 2 plus c. Again, this negative, I don't need to distribute it to the c because negative c is just another constant, so we just call it c. Okay, so negative 2 over 3. I'm going to place my cotangent in place of the u. So cotangent of x all to the power of 3 over 2 plus c. Okay, good. Next question. It says take the integral of arctangent all squared divided by x squared plus 1. For this we have to remember that first off, arctang of x is just another way of saying tan inverse of x. Okay, so we have to know that the derivative of tan inverse of x, we have to remember this, is 1 over x squared plus 1. Okay, and so this fits in well here. We can get our u as arctan of x. Our du would be 1 over x squared plus 1 dx. That's the derivative of arctan. And now we can just substitute this into our integral. So our integral will just be u squared du, right? The du takes care of this 1 over x squared plus 1 dx. And to integrate that, I'll just get u to the power of 3 over 3 plus c, and I'll substitute my u back in, my arctan for u. So I'll get arctan of x all to the power of 3 divided by 3 plus c, and that would be my final answer. Next question. It's the integral of sine of 2x all over 1 plus cosine squared x dx. Okay, so before we begin this question, I want you to remember that sine of 2x is equal to 2 sine of x cosine of x. Okay, so we need this identity. Once we know this identity, or if you can recall this identity, then this question becomes easy. So I'm going to let my u here be 1 plus cosine squared of x, and du would be the derivative of that. Well, the 1 goes away. In the derivative of cosine, I'm going to derive cosine squared of x using the chain rule. So cosine squared of x, we can rewrite it as cosine of x all squared. And using the chain rule, we can derive this. With the chain rule, recall that if you had, say, 3x plus 1 squared, you would take the derivative of the whole thing. So the derivative of this would just be 2 into 3x plus 1. That's the derivative of the whole thing. And you multiply by the derivative of the inside, which is 3. I'm going to do the same here for cosine squared. So the derivative of the whole thing would be 2 cosine of x, and then the derivative of the inside of cosine would be negative, so I'll multiply by negative sine of x. So in fact I'll end up with negative 2 sine of x cosine of x for the derivative of cosine squared. So my du here would just be negative 2 sine of x cosine of x dx. Okay, so once I see that, I can rewrite my integral here of sine of 2x, integral of sine of 2x over 1 plus cosine squared of x dx. Well, that's just equivalent to, I'm going to use my identity here. I'm going to say sine of 2x equals this here, 2 sine of x cosine of x all over 1 plus cosine squared of x dx. Okay, now once I've got my integral looking like this, I've got a nice easy u substitution. So I have my u here, I'll integrate here. I don't need a negative 2, I just want a 2. So I'll take this negative, I'll move it here. So I'll have a negative outside. I'll have 1 over u du, and the du takes care of the 2 sine x cosine x dx, and the u is the 1 plus cosine squared of x. And I can integrate this easily, but first I'll rewrite it as integral of u to the power of negative 1, and that would be, in fact here it will be negative ln of u. The integral of 1 over u is just the natural log, or the absolute value of the natural log of u, plus c. And that would simplify to, if I put my u back in, I'll get negative ln of 1 plus cosine squared of x plus c. Good. Let's go to the next question. Okay, this is a definite integral, so we're going to evaluate it and then place values in to find the actual area that would be under this curve. The u substitution here would be easy. I think you can see it. It's u would be ln of x, and the derivative of that is 1 over x dx, which is exactly what we want, 1 over x dx. So I'll substitute that in. I'll have the integral of 1 over square root of u du. Before I integrate, I'm going to rewrite it as u to the power of negative a half du, and I'll integrate now. I'll get u to the power of a half all over a half plus c. That changes to u to the power of a half multiplied by 2. This dividing by half is like multiplying by 2, plus c, and this u is just ln of x, so I'll get 2 ln of x all to the power of a half plus c. Okay, so I'm going to remove this c here because I'm actually going to put in numbers now. It's going to be from e to e to the power of 4. Alright, so first I'll place this e to the power of 4 into my formula. I get 2 ln of e to the power of 4, and then I'll place this to the power of a half, and then I'll have minus, I'll place the e now in, 2 ln of e all to the power of a half. Okay, so I'll move here now. I'll get 2, and if I simplify this, ln of e to the power of 4 is just going to be 4 to the power of a half minus, well, ln of e is just e to the power of a half, I'll take this out here, minus e 2e to the power of a half. Okay, sorry, this is wrong. This would not be minus 2e to the power of a half. It will be ln of e, which is just 1, right? So it'll be 2 into 1 to the power of a half. And that just becomes 2 to the power of a half means square root, so 4 to the power of a half is just 2 minus 2, which will be 4 minus 2, which is 2. Okay, next question. Alright, so we've got an x squared here and an x, so we'll do u substitution. We'll take our u as x squared. So we'll have u equal to x squared. Du would just be 2x dx, but we only want an x, we don't want 2x, so we'll divide by 2. So we'll get a half du equals x dx. Well, now I'll substitute. I'll leave the half outside, and I'll have e to the power of negative u du. Alright, notice this is also a definite integral, so in the end we'll have to place these values in and actually find the area under the curve. Okay, so here we'll have, if we integrate this, we'll have a half into the integral of e to the negative u will just be negative e to the negative u, and this would be a half multiplied by 1 over e to the u, and that will simplify to negative 1 over 2 e to the u. And now I'll substitute in x squared for u. I'll get negative 1 over 2e to the power of x squared, and I'm going to have to take that from 0 to 1. Alright, so I'll place 1 in first, so I'll get minus 1 over 2e to the power of 1 squared, and then place 0 in, that'll be negative minus a negative, so it'll be plus 1 over 2e to the power of 0 squared. Alright, that just simplifies to negative 1 over 2e plus, well, e to the power of 0 is just 1, so I'll get 1 over 2 here. And that would be the final answer. Alright, I think this is the last question. So we've done 20 questions from the U substitution section 4.5. U substitution is very important for Calculus 1 and Calculus 2 actually, especially for Calculus 2. So it's a good idea to make sure you know it very well before we move on. And as you noticed here, the hardest things really are just knowing the identities and the standard derivatives and standard integrals. If you know the standard derivatives, then identifying a U substitution becomes very easy. Alright, so my advice would be just practice as much as you can, look at the suggested exercises, go back, make sure you're familiar with all the integrals and standard derivatives, and you should be fine. Alright, thank you for watching.